This video goes through the exponential rule, so it summarizes everything. To begin, let's look at notation. So if I have a to the m, the a is what we call our base. And the m, which is a little exponent or power or index, all of those things mean the same thing. So we say a to the power of m. When looking at what that means, if I come to my table, in my expanded notation, I have -4 times -4 times -4. So that means my -4 is to the power of 3. My base is -4 and my power is 3. And it's really important to put that -4 in brackets because it's all of that to the power of 3. And that is really, really important because what if I had -4 cubed? That actually means -4 times 4 times 4, which is -256. Now, not a big deal with a odd power because no matter what, if I went -4 times -4 times -4, I'm still going to get a negative answer. Okay, but if it's an even power, then that's where our difference will occur. So just to explain that further, if I have -2 to the power of 4, that's actually equal to +16 because it's -2 times -2 times -2 times -2. There's an even number of negatives, so they all pair up and become positive. Remembering, two negatives when multiplied equal a positive. In contrast, if I had -2 to the power of 4, my answer is actually -16. So be careful of the brackets, be careful of negatives. And just to summarize that, if I have a negative base and my power is even, so what you can see over here, then my answer will always be positive. Because of the two negatives when multiply equal a positive, those negatives pair up. In contrast, if I have -m and I have an odd power, then my answer will always be negative because there'll be a little negative left over that can't pair up. Coming back to my table, if I have 3 to the power of 7, it's 3 times 3, and I have to keep doing it 7 times. So 1, 2, 3, 4, 5, 6, 7. So my base is 3 and my power is 7. Next one, my base is a over 2 and my power is 5. So that's a over 2 multiplied by each other 5 times. And in index form or exponent form, a over 2 has to be in brackets and it's to the power of 5 because it's both the a and the 2 that is to that power of 5. So remember the brackets. Last one, 2b times 2b times 2b. Again, the 2b is in brackets and it's to the power of 3. If I wrote 2b to the power of 3 and I forgot the brackets, then the only thing to that power of 3 is the b. So that would actually be 2 times b times b times b, which is very different. Finishing up the table, the base is 2b and the power is 3. Now let's going into some rules. A to the m times a to the n is a to the m plus n. So I add my powers. And the reason for that, if I have 2 squared times 2 cubed, the 2 squared is 2 times 2, and the 2 cubed is 2 times 2 times 2. And then I have that multiplication sign in the middle. So that's actually 2 to the 1, 2, 3, 4, 5, 5. Or I could have thought of it as being 2 to the 2 plus 3, which is 2 to the 5. So that's where that rule is coming from. So my answer here is 3 to the power of 2 plus 1. Now there's a 1 here that we don't write, don't forget it, plus 4. So that's 3 to the 2 plus 1 is 3, 3 plus 4 is 7. Now whenever I have a number to a power, I go to my calculator and evaluate it. So 3 to the power of 7 is 2187. Next one, we look at our numbers first. So we have 2 times 4, so that's 8. And then we look at our a's. Remembering we can only do these rules when our base is the same. So we have 3 plus 7 plus, and there's a 1 there. So it's 8a. 3 plus 7 is 10. 10 plus 1 is 11. Next, again, we have some negatives here, so I'm going to look at those first. I have 2 negatives, so my answer, and I don't have to write the positive, but just to point it out, my answer is positive. My numbers are 2 times 3, and 2 times 3 is 6. Then I look at my a's. For my a's, I have a squared times a cubed. So that is a to the 2 plus 1 plus 3, and then b, for my b's, it's not going to work very well because it covers. So I'll use a lighter pink. So I've got b cubed times b to the 4, and that's all I've got. Sorry about that, my pen's decided not to write. So b cubed, so it's 3 plus 4. So my answer is 6a to the 6, b to the 7. Moving on to division, a to the m divided by a to the n, or I could write it as a to the m over a to the n, is a to the m minus n. And again, I'll show you why. If I have a to the 5 over a squared, that's a times a times a times a times a, all over a times a. These a's cancel, so I'm left with a cubed, or a to the 5 minus 2, which is a cubed. So that's where the rule is coming from. So 4 to the 7 divided by 4 squared is 4 to the 7 minus 2, which is 4 to the 5. And again, I could go to my calculator because it's number and evaluate that. It is 1024. Next, I have to look at my numbers first. So I've got 12 divided by 4, and that's 3. Now, if that wasn't exact, then I'd have to use fractions, and that's also okay. And then I look at my a's. A to the 9 divided by a squared is a to the 9 minus 2 is 3a to the 7. Next, it's actually in fractional form, and that's good because I can't do the division of the numbers exactly. So 15 over 20, I can do 5 into 15 is 3, 5 into 20 is 4 times. So I simplify just like I would fractions at any other time. And then I look at my a's, and then I'll look at my b's. Okay, so my answer becomes, I've got 3 over 4, a to the 10 minus 2, b to the 7 minus 1. So it's 3a 10 minus 2 is 8, b 7 minus 1 is 6, all over 4. Okay, I could also write that as 3 over 4, a to the 8, b to the 6. Next, powers, a to the m or to the n, we multiply. Okay, so whenever we have it in brackets and we have a power of a power, we multiply our powers. Now note, that's really the only rule you need to remember. The other two that I have here are just derivations of previous rules. So AB or to the m is a to the m, b to the m. A over b or to the m is a to the m, b to the m. So really it's just like previous rules. It just means that if you've got a power, then you multiply. So here I've got 3 squared or to the power of 4 will be 3 to the 2 times 4, which is 3. 2 times 4 is 8, and 3 to the power of 8 on our calculator is 6561. Next, the 3 out the front isn't inside the bracket, so it just stays there. Then I have the negative 2, and I'm putting it in brackets to the power of 4 because it's all of it to the power of 4. My a squared to the power of 4 is 2 times 4, and then my b is 3 times 4. So I have 3 bracket, negative 2 to the power of 4 is negative 2 times negative 2 times negative 2 times negative 2. So there's an even power, so my answer is positive. So it's going to be 16. A, 2 times 4 is 8. B, 3 times 4 is 12. 3 times 16 is 48. A to the 8, B to the 12. Next, just A cubed over B cubed. Next rule, powers of 0. Anything to the power of 0 is 1. So 1,234 all to the power of 0 is 1. Everything inside this bracket is to the power of 0. So my answer is just 1. In the next one, everything inside the bracket is to the power of 0, but that 10 isn't. So my answer is actually 10 times 1, which is 10. So be careful. Might be a question trying to trick you. Negative powers. We always express with positive powers when we're doing exponentials, and we do that. So if we have something to a negative power, we put it 1 over. So if I have 4 to the negative 2, I can rewrite that as 1 over 4 squared, which is 1 over 16. So next, the only thing to the negative is that A. That 4 isn't. So 4 stays there, but A negative 3 goes to the bottom to make it positive. And similarly, if it goes to the denominator to make it positive, if the negative is in the denominator like it is here, then it's going to go up to the top to make it positive. So that's 5A to the 4. And then roots, A to the 1 over n is the nth root of A. So 9 to the power of half, I could write is the second root of 9, but we never write that 2. Whenever we just see a square root, it's assumed that it's a 2. And the square root of 9 is 3. So the next one we have a to the power of third, so that's a cubed root. So 27 a cubed b to the 12 is one option, but there's a better way of doing this question. And that's just to evaluate it like powers up here. Okay, so we've got 27 to the power of a third, a 3 times a third, b 12 times a third. Now 27 to the power of a third is a cubed root of 27, or you could put it on your calculator as 27 to the power of a third. It's 3. 3 times 3 times 3 is 27. A, 3 times a third is 1, so I don't need to write the power. B, 12 times a third is 4. Now just writing this in terms of a root is 4a squared b cubed. It's the 3's on the bottom, so that's a cubed root, and then the 2 goes all the way around that. So it's the cubed root of all of that squared. So that's the cubed root. 4 squared is 16. A, 2 times 2 is 4. B, 3 times 2 is 6.